There are 5 ways to prove that a quadrilateral is a parallelogram. We can use the definition, prove that both pairs of opposite sides are parallel. If both pairs of opposite sides are congruent, that's a parallelogram. If both pairs of opposite angles are congruent, it's a parallelogram. If the diagonals bisect each other, it's a parallelogram. And finally, if the same pair of sides is both parallel and congruent, you've got yourself a parallelogram. So, including the definition, there are 5 ways to prove that a quadrilateral is a parallelogram, and these are they. Now, for this homework, this first part, we're supposed to say what theorem you can use to show that the quadrilateral is a parallelogram. Basically, we're supposed to list one of these 5 things. So, for this one, we really need to know what this missing angle is to be able to do anything else. So 105, 105. So the total degrees in a quadrilateral is 360. So I'm going to subtract 105 minus 105 minus, I think the other one was 75. That leaves 75 degrees. Okay, so that means this missing angle right here is 75 degrees. So, opposite angles are congruent. Opposite angles are congruent. That's how we know that one. 73, 73, 98, 98. Opposite sides are congruent. Look at how these pieces are congruent. In other words, the diagonals bisect each other. Okay, see how we're just using these things? Opposite sides congruent, opposite angles congruent, diagonals bisect. We haven't used this one yet. The same pair of sides is both parallel and congruent. Watch out for that. Oh, look, number 4. See how we have the same pair of sides. Alright, the sides that I just colored in red, those are parallel. You can tell because of the arrows that were given. And they're also congruent because of the 10 on both. So, same pair of sides is both parallel and congruent. Okay, feel free to use the symbols just like I'm doing. Okay, so that's how you do that. For what value of x is the quadrilateral a parallelogram? Well, if it's a parallelogram, the diagonals bisect each other, meaning these pieces should be equal to each other. So, alright, so that should be your answer number 5. Number 6 is pretty much the same thing. These diagonals will have to bisect each other, so these pieces should be equal. Okay. Number 7. Wow, all these seem like they are the same thing. Alright, that's answer number 7. Okay. For number 8, if this is going to be a parallelogram, alright, if I add 101 plus 101, okay, that gives us 202. Okay, if I subtract from 360, so let's do 360 minus 202 and see what's left. That leaves 158. Now that 158, whoops, that 158 is going to have to be shared equally between this angle and this angle, alright, because that's what's left for these two and they should be congruent. So let's do 158 divided by 2, and that should be it. 79. Okay, so that tells me that x should be 79. Alright, think about it. If I had 79 and 79, it would all add up to 360. That's the key. Alright. Are these angles going to be equal to each other? No, they will not. These angles, see how I just circled them? They are on the same side. They are consecutive. That means they should add up to 180. Okay, they should be supplementary. So okay, that's number 9. And this is the same thing. These are angles, and they are consecutive angles. They're not opposite. One's acute, one's obtuse. They should be supplementary. So they should add up to 180. So in other words, x plus 1 plus 5x minus 7 should equal 180. Like terms, so that's 6x minus 6 should equal 180. The 6x came from doing the x, and the 5x gives me the 6x. And of course the negative 6 comes from doing the 1 and the negative 7 together make the negative 6. Okay, that is how you do that. Moving on. Name each quadrilateral. We're going to either call it a parallelogram, a rectangle, rhombus, or square, for which the statement is true. Okay. Equiangular. That means all the angles are the same. Alright, that's going to be true for a rectangle, because that has 4 90-degree angles, so of course all the angles are the same. And a square is a special kind of rectangle. It has 4 right angles too, so same deal. That's it. Those are the only 2 that are equiangular. Which ones have diagonals that are perpendicular? Well, that's only going to happen when you're looking at a rhombus. Okay, because those are the part of the special properties of a rhombus, are diagonals are perpendicular. And a square is, every square is a rhombus, so that'll be true for a square too, because a square is just a special kind of rhombus. The diagonals bisect each other. Well, that is a parallelogram property. So that's going to be true for all parallelograms, which of course will include the rectangle, rhombus, and square. Okay, so all 4. Equiangular and equilateral. That equiangular means all the angles are the same. Equilateral means all the sides are the same. Well, the ones that were equiangular were rectangle and square because they had all the 90 degrees, but only the square is going to also have all the sides the same. So the number 14 is just only a square. Satisfies that one. Okay, we have to classify and then find x and y. Well, this is clearly a square. The definition of a square is it's a rhombus and a rectangle. The 4 congruent sides make it a rhombus. The 4 90-degree angles make it a rectangle. So by definition, this is square. So I'm going to go ahead and set the 5y plus 1 equal to the 2y plus 4. Now, I could set opposite sides equal to each other, but those a y and an x, so that's not going to help me. But because all the sides are congruent, there's nothing to stop me from setting, you know, this one congruent to that one. And there's nothing to stop me from setting this one congruent to that one, because all the sides are congruent. So why not do the ones with the variables that I need? Okay, so I found the value of y. Now let's find the value of x. I'm just going to set these equal to each other now. Okay, and that's the value of x. Okay, let's see. Number 16. Four congruent sides, that makes this a rhombus. That's the definition of rhombus. It's not a square, because otherwise that would be 90 degrees. So this is a rhombus, but all the sides are equal, so I can definitely find y by setting these equal to each other. So let's start by doing that. Alright, so there's the value of y. Now, the value of x, okay, let me just get this out of the way. Okay, this is a rhombus, so there's going to be symmetry. You know, if this is 127, then this is going to be 100. Whoops, why did I put a 5? Then this is going to be 127 degrees. You know, the whole quadrilateral has to be 360, so let's do our 360 minus 127 minus 127. That leaves 106 to be shared equally between two angles, so let's divide that by 2. So that's 53. Okay, so that means this angle is going to be 53, and this angle is going to be 53. Again, what I did was I started with a total of 360, and I subtracted the two 127s. So I meant, why do I keep putting 5? So I meant minus 127 minus 127. That left 106. For the other two angles. So I went ahead and divided by 2, and that's where I got the 53 from. Okay, OBKB, but that means that this angle right here must be 53. That's where I'm getting this equation from that I'm about to write down right now. 2x minus 1 should equal 53. Okay, so x should be 27. Alright, let's see what's next. The diagonals of rhombus PQRS intersect at T. Given that angle RPS, this one right here is 30, and RT, which is right there, is 6. Find the indicated measure. Okay, so angle QPR, got to find angle QPR. QPR is this angle right here. Well, one of the properties of a rhombus, let's not forget this is a rhombus, is that the diagonals are angle bisectors. So this angle is being split in half. So if this is 30 degrees, then this angle is also 30 degrees. So for that reason, this is 30 degrees. We're also supposed to find angle QTP. Okay, angle QTP is this angle right here, Q to T to P. So the red angle I just drew is angle QTP. Well, one of the properties of a rhombus is that the diagonals are perpendicular. So QTP has got to be 90 degrees. And let's see, we're supposed to find the length of RP. Well, RP is this whole length from here to here. For any parallelogram, the diagonals bisect each other. So if this side is 6, then from P to T, this should also be 6, for a total of 12. So that should be number 19. Okay, this is a rectangle. So the diagonals should be congruent. Alright, in addition to being given that this angle right here is 50, we're also given that XZ is 12. So let's be sure we understand that this is 12. So let's see, what do they want? Angle WXZ. So WXZ is this angle right here that I'm going to go ahead and show in green. Alright, so we're being asked, it's not really bright enough. Okay, we're being asked for the green angle here. Well, this is a rectangle, yes? So if that's a rectangle, that means each one of these corners is 90 degrees. So this must be 40. Okay, I'm getting that because I just did 90 minus 50, because this part is 50. So that leaves 40 for the other side. So the green angle WXZ should be 40 degrees. Okay, this color's not working for me though. How about angle WPX? Okay, angle WPX. Alright, that's this angle right here that I'm highlighting in purple right now. Okay, WPX. Now, this is not a rhombus, so I do not automatically know that this is 90 degrees. However, because of the symmetry, of this picture, let's see if I can get rid of this for a second. Alright, because of the symmetry I can tell you that this, see how this is 40 degrees over here? Then this is also going to be 40 degrees. You know, a rectangle is always going to have this kind of balance to it on the left and the right. So that's 40 degrees, that's going to be 40 degrees. So anytime I have two angles in a triangle, I can always get the third. In fact, that's 80, so this must be 100. Alright, but technically I'm doing this. I had my two angles that were 40, and I'm subtracting from 180. So I went 180 minus 40 minus 40. Okay, that was 100. Okay, so I know that angle WPX is 100 degrees. Alright, now how about PY? Well, that's going to be 6. How do I know that? Well, remember they told us that XZ is 12. So XZ is this diagonal that I'm just did in red. Okay, that whole thing is 12. Okay, if that's 12, then that means that these pieces are 6. And since the diagonals of a rectangle are congruent, it's going to be the same thing going the other way. 6 and 6. All four of these pieces have to be 6, including PY has to be 6. So that's where I got that from. Okay. Square DEFG. This is a square. And the diagonals are what they are. So, given that EH is 5, look, this is a square, so yeah, that means it's a rectangle, so the diagonals are congruent. So all these little pieces are 5. So that's going to be good to know. Also, this is a rhombus, so that means this is 90 degrees in here. Okay, a square, every square is also a rhombus. So let's see what they actually ask us for. Angle GHF. Angle GHF is this angle right here. Okay, that has got to be 90 degrees. Because the diagonals of a rhombus are perpendicular, and a square is just a special case of a rhombus. Okay, number 26, DGH. Angle DGH. So say DGH. Alright, angle DGH is this angle right here, from D to G to H. This is angle DGH. Well, that angle has to be 45 degrees. I got that because this is a square, so the entire corner, you know, say the entire corner from here to here, say, the purple is 90 degrees. I need to erase some of this other stuff. Yeah, okay, so this purple angle all the way across is 90 degrees because it's a square, it's a corner of a square. But remember, the diagonals in a rhombus are angle bisectors. So I just did 90 divided by 2 because this angle should be split right down the middle, because a square is a special kind of rhombus, and the diagonals of a rhombus are angle bisectors, so 45 degrees. Okay, what about HF? HF, like I mentioned earlier, is going to have to be 5. HF is this distance right here. But because of the way the diagonals are congruent and the way the diagonals bisect each other, all these pieces are going to have to be 5. 5, 5, 5, and 5, including HF. Let's see, what about DE? Okay, DE. For DE, we're finally going to have to use the Pythagorean Theorem. Okay, looking at this triangle that goes like this, okay, looking at that triangle right there, okay, see that yellow triangle? Okay, so focus on this triangle. I have the two sides of the triangle, the two legs, and then the hypotenuse. So a squared plus b squared equals c squared. Okay, maybe I can squeeze this in underneath. And maybe I can erase the stuff that I don't need right now to make it more clear. Okay, so looking at this triangle, what I have here is 5 squared plus 5 squared equals x squared. A squared plus b squared equals c squared. I'm doing the Pythagorean theorem. So that's going to be 25 plus 25 equals x squared. So that's going to be 50. Take the square root of both sides. Alright, so square root of 50, that's 5 radical 2. So that gives us 5 radical 2 is equal to x. So that was the length of DE. So DE is 5 radical 2. And that, I believe, is the end of the homework.